A dangerous and increasingly rare atmospheric setup is locking into place over the eastern United States right now, and the people paid to watch the sky for a living are not using calm language about it. Over the next 10 days, the East Coast is going to face heat that can kill a healthy adult in hours, rainfall rates that will overwhelm cities that were never built to handle them, and a severe weather window that has forecasters circling specific days on the calendar with the kind of urgency that does not show up often. By the end of this, you will understand exactly what is coming, why it is coming, and what the next 10 days could cost. What's actually building right now. Let's start with the atmosphere, because before you can understand what is about to happen to 70 million people on the eastern seaboard, you need to understand the machinery that is assembling itself above them right now. There are 3 separate atmospheric systems converging on the East Coast simultaneously, and the reason forecasters are worried is not any one of them in isolation. It is what happens when all 3 arrive at the same time, in the same place, and refuse to move. The first is a blocking high, a high-pressure system sitting over the western Atlantic, anchored like a boulder in a river. Normally, weather systems move. They slide east, they break apart, they get pushed offshore by the next system coming down from Canada. That is how the atmosphere cleans itself. A blocking high stops that process. It parks itself in the upper levels of the atmosphere and forces everything trying to move east to stall, back up, and sit. Think of it as a traffic jam, except instead of cars, it is heat, moisture, and the storms they generate. And the jam is not clearing for the better part of 10 days. The second player is a Gulf moisture surge. The Gulf of Mexico is running above normal sea surface temperatures right now, and a warm Gulf is a pump. It sends warm, water-laden air northward along the eastern seaboard with a consistency and volume that turns the entire corridor from Georgia to Massachusetts into something resembling coastal Louisiana in the worst possible way. When meteorologists talk about Gulf moisture surges, they are talking about the atmosphere essentially pressure washing the East Coast with humid air from the south. Dew points, the measurement that tells you how much water vapor is actually in the air you are breathing, are forecast to climb into the upper 60s and low 70s Fahrenheit across a huge swath of the mid-Atlantic and the Northeast. That is a number that should make you sit up, and we will come back to exactly why in the next chapter. The third piece is a stalled frontal boundary draped across the Carolina coastline, a front that cannot move because the blocking high will not let it. And a front that cannot move is not a front anymore. It is a focal point, a line of perpetual conflict where cold air trying to push south meets warm air trying to push north, and neither side wins, and the result is rain, more rain, and then storms day after day after day, anchored to the same geography. From Maine to Florida, but most intensely from the Carolinas through the mid-Atlantic up into southern New England, these 3 systems are about to work in concert for 10 straight days. That is the setup. And now let's talk about what it actually does to people. The heat weapon, what this kind of humidity does to a human body. Here is the number that should worry you more than anything your weather app shows you this week: wet bulb temperature. Most people have never heard of it. Every heat researcher in the country considers it the single most important metric for understanding when heat stops being uncomfortable and starts being lethal. Your app is going to tell you it is 94 degrees in Philadelphia on Thursday. That sounds bad. It is bad. But 94 degrees in dry air and 94 degrees with a dew point of 72 are 2 completely different physiological events happening inside your body. Same number, completely different outcome. Here's the physics, and it is worth understanding. Your body cools itself by sweating. Sweat evaporates, carries heat away. Core temperature stays stable. Elegant system. One requirement, the air around you has to be dry enough to accept that moisture. When the dew point pushes 70 and above, the air is already so saturated that evaporation slows to a crawl. Your cooling system does not fail dramatically. It just gradually loses the argument with the heat. And at some point, your core temperature starts climbing. That is not a bad day anymore. That is a medical emergency developing in real time. And you may not feel it happening until it is advanced. Researchers at Penn State established that a wet bulb temperature of 35 degrees Celsius, 95 Fahrenheit, is the absolute physiological ceiling for an average adult at rest in the shade. Above it, the body cannot shed heat faster than it accumulates it. Full stop. We are not forecast to hit that ceiling everywhere. But Washington, Baltimore, Philadelphia, and New York are forecast to sustain wet bulb temperatures between 30 and 32 degrees Celsius for multiple consecutive days. That is not the lethal ceiling. It is the range where elderly adults, infants, people with cardiovascular conditions, and outdoor workers start dying in measurable numbers. And then there is the detail that quietly makes everything worse: nighttime. The human body uses overnight hours to recover from daytime heat stress. When the temperature at 2 in the morning is still 82 degrees, that recovery never happens. The damage accumulates. By day 4 or 5, people who seemed completely fine on day 1 are in crisis. The models are projecting exactly those overnight lows across the urban corridor for the back half of this 10-day window. That is not a heat wave. That is a siege. The flood machine. Why the rain events this week are different. If the heat were the only threat this week, it would be enough. It is not the only threat. That stalled frontal boundary sitting across the Carolinas is going to do something meteorologists call training. Storm cells form repeatedly over the same geography, one after another, like train cars passing over the same section of track. Each cell drops its rainfall on ground the previous cell already saturated. The totals accumulate far beyond what any single storm would produce. And the atmosphere feeding this system right now has the fuel to keep that train running for days. Precipitable water values across the Carolinas and southern Virginia are forecast to run 1.5 to 2 inches above seasonal norms. That sounds like a minor deviation. It is not. At those levels, when a storm taps into that column of moisture overhead, rainfall rates can hit 2 to 3 inches per hour. 2 to 3 inches per hour is not rain. It is a pressure washer aimed at the ground. Here's why that matters specifically for cities. Urban surfaces, concrete, asphalt, rooftops, parking lots are nearly impermeable. Water cannot soak in. It has to go somewhere, and that somewhere is a stormwater drainage system that, in most eastern seaboard cities, was engineered in the 1950s and 60s for roughly 1 inch of rain per hour. When 2 to 3 inches arrive instead, the system backs up instantly. Water finds the next lowest point, which in a city is a road underpass, a subway entrance, or someone's basement. People drown in their cars in highway underpasses during events like this, and it happens because the water rises faster than most people believe is physically possible. There will be a flash flood watch or warning covering some part of the East Coast for most of the next 10 days. For some communities, that is not a forecast of inconvenience. It is a forecast of catastrophe. The storm threat. Severe weather outbreak window. Now here's the part where the heat and the moisture and the stalled front all decide to have an argument, and the argument produces tornadoes, large hail damaging straight-line winds, and the specific phenomenon that deserves its own paragraph because most people have never heard of it, and it is arguably the most underrated severe weather threat in the eastern United States: a derecho. A derecho is a widespread, long-lived windstorm associated with a band of rapidly moving showers or thunderstorms. The name comes from the Spanish word for straight, as opposed to the rotating winds of a tornado. A derecho produces damage in a continuous swath that can stretch for hundreds of miles, sustained wind gusts exceeding 58 miles per hour by definition, and frequently producing gusts of 80, 90, or over 100 miles per hour in the strongest events. It is essentially a hurricane-force wind event that requires no tropical system to form, materializes with relatively little warning compared to a tropical storm, and can cross from western Pennsylvania to the Atlantic coast in under 6 hours. The setup for the severe weather outbreak window falls in the middle portion of the 10-day period, when the temperature contrast between the hot, humid air mass locked in place over the coast and a disturbance pushing east along the stalled front creates the wind shear profile that severe weather researchers associate with organized, long-track storm systems. The mid-Atlantic corridor, roughly the zone from the western Carolinas through Virginia, Maryland, and into southeastern Pennsylvania and New Jersey, is currently the highest probability bullseye for the most significant severe weather day in this period. This is not a forecast I am generating from instinct. This is what the Storm Prediction Center's extended outlooks are gesturing toward. And the Storm Prediction Center is not an organization that uses the word significant casually. For context on what a major derecho does to an area, we will get into the historical record in a few minutes. But the short version is this: a significant derecho event in a densely populated corridor like the Mid-Atlantic is not a weather event that inconveniences people. It is a weather event that kills power for millions, knocks trees onto occupied homes, and overwhelms emergency response systems in ways that take days to a week to recover from. Timed against a heat event already underway, a multi-day power outage in the conditions forecast for this period is not an emergency. It is a compounding catastrophe. The infrastructure problem. Nobody wants to talk about. Let's talk about the grid, not in an abstract policy sense, but in the specific practical sense of what happens when you take an electrical infrastructure that was largely built in the mid-20th century and ask it to perform under conditions that mid-20th century engineers were not designing for. The Eastern Interconnection, the grid that serves the vast majority of the East Coast, is under persistent strain during major heat events for a straightforward reason. When it is hot, everyone runs their air conditioning simultaneously, and peak electrical demand spikes to levels that test the system's capacity. During the extended heat events, comparable to what is forecast for this period, grid operators issue emergency alerts and ask large industrial consumers to voluntarily reduce usage. That is not a sign of a comfortable margin. That is a sign of a system operating near its ceiling, now at a derecho. A major windstorm crossing the mid-Atlantic can knock out transmission infrastructure, transformer stations, and distribution lines across a geographic footprint that takes weeks of crews working around the clock to fully restore. The combination of heat-driven maximum demand and storm-driven supply destruction is the scenario that keeps grid operators awake. And it is the scenario currently on the table. But the infrastructure problem is not just about the grid. It is about who lives where and what resources they have access to when the grid fails. Urban heat islands are a real, measurable phenomenon. Dense urban cores with their concentration of heat-absorbing surfaces, limited tree canopy, and waste heat from vehicles and buildings run measurably hotter than surrounding suburban and rural areas. During the heat event forecast for this period, the difference between the official high temperature recorded at an airport weather station and the actual temperature experienced by a resident of a dense urban neighborhood can be 5 to 10 degrees Fahrenheit. That gap is not trivial. That gap is the difference between uncomfortable and dangerous. And the people living in the hottest urban microclimates are disproportionately the people with the fewest resources to protect themselves. No air conditioning or air conditioning they cannot afford to run. Older housing stock with poor insulation that traps heat, limited transportation access to cooling centers, pre-existing health conditions that elevate their vulnerability. The forecast does not affect every zip code the same way. It never does. And the communities bearing the highest risk from this event are frequently the communities that receive the least advance warning, the least media attention, and the least post-event support. This is not a political statement. It is a documented pattern that shows up in the mortality data from every major urban heat event in the historical record. The zip code you live in is one of the strongest predictors of whether a heat event like this one kills you. That deserves to be said plainly. The historical precedents. When the East Coast got it wrong. The eastern United States has a track record with compound weather events like this one, and that track record is not reassuring. Start with 1995. Chicago gets the headlines for that summer's heat wave, and it deserves them, with over 700 excess deaths in 5 days. But it was not a Chicago event. It was a national event. The eastern seaboard bore significant mortality in cities that received far less attention, and one finding from the postmortem still haunts heat researchers today. Many victims were found alone in their apartments with the windows closed. They had not opened them because they were afraid of the neighborhood outside. They chose a known danger over an invisible physiological process they did not understand. That is not ignorance. That is a rational response from people who did not have good options. Now move to June 29th, 2012. A derecho crossed the entire mid-Atlantic in roughly 11 hours, knocking out power to 3.8 million customers across 10 states. Then the heat arrived immediately because it was late June. People did not die from the storm. They died from the heat that the power outage left them defenseless against, with some outages lasting over a week. The derecho was not a weather event. It was the opening act of a 10-day survival situation. And then there is Ellicott City, Maryland, which flooded catastrophically in 2016, killing 2 people and destroying over 100 businesses in roughly 2 hours of rain. Then flooded again in 2018. Same place, same geography, same result. What all 3 events share is a gap between what the atmosphere was capable of producing and what affected communities were prepared to handle. That gap is about to open again. The 10-day breakdown, day by day. Let me give you the actual timeline because this is not a uniform 10-day threat. Different days carry different threats, and understanding the sequence matters for understanding how the compound nature of this event builds. Days 1 through 3 are the setup phase. The blocking high consolidates its position over the western Atlantic. Gulf moisture begins pushing north along the coast. Temperatures climb above seasonal norms from Georgia through southern New England, with the most significant anomalies in the mid-Atlantic. Dew points begin their climb into the mid-60s. The atmosphere is loading the gun. Rain chances exist, particularly near the stalled frontal boundary in the Carolinas, but this is not yet the primary threat window. This is the phase where people look at the forecast and think, hot and a bit humid, nothing unusual for summer. That assessment will prove incorrect. Days 4 through 6 are the first major threat window. The moisture surge reaches its peak intensity across the mid-Atlantic and southern New England. Dew points in the upper 60s to around 70 are widespread from Washington through Philadelphia and into the New York metropolitan area. Heat index values, the official measure the National Weather Service uses to communicate the combined effect of heat and humidity, reach 105 to 110 degrees across a broad area. The National Weather Service issues excessive heat warnings. The frontal boundary in the Carolinas activates in the overnight hours, generating training rainfall events with localized totals of 5 to 8 inches, possible over 24 to 36-hour periods across Western Carolina and the Virginia Piedmont. Flash flood emergencies are likely during this window. The overnight lows during this stretch are the metric to watch. If they stay above 80 degrees in the urban corridor, day-over-day heat stress accumulation begins. The grid is running at or near peak demand. Day 7 is the day to mark on your calendar right now. This is where the current forecast guidance is most alarming and, to be honest, most uncertain, but uncertain in the direction of more dangerous rather than less. An upper-level disturbance is forecast to interact with the stalled front and the loaded moisture environment across the mid-Atlantic corridor. The Storm Prediction Center's guidance for this period suggests a significant severe weather event is possible, with the primary risk area centered on the mid-Atlantic, encompassing western Virginia, Maryland, southern Pennsylvania, New Jersey, and Delaware. The derecho threat is real on this day. If a bow echo develops and the wind shear profile confirms what the current models are suggesting, the event on day 7 could produce widespread wind damage across the highest density population corridor in the entire country. This is the day that determines whether this 10-day stretch becomes historically notable or merely significantly bad. The model spread on day 7 is still meaningful, so track the updates daily as this window approaches. The atmosphere is going to make this decision in real time, and the closer we get, the clearer the answer becomes. Days 8 through 10 are the back end of the event, and this is where the compound nature of the threat becomes most acute. If the power outage scenario from the day 7 severe weather event materializes, days 8 through 10 are the survival window. Heat is not forecast to relent significantly. Another moisture surge is possible. The ground is saturated from the training events earlier in the period. Additional rainfall during days 8 through 10 runs off on soil and urban surfaces that have no remaining absorption capacity, meaning flash flood risk remains elevated even from relatively modest rain events. Emergency management resources, if stretched by storm response, are simultaneously being asked to manage heat-related illness surges, flooding rescue operations, and whatever additional severe weather develops. This is the phase that historical compound events teach us is the most deadly. Not the dramatic peak of the primary event, but the grinding aftermath, when resources are depleted and attention has shifted, and the people still in danger are the ones nobody is checking on. The bigger picture. Why this keeps happening. If you have been watching this channel for any length of time, you know I am not in the business of attaching every extreme weather event to a single cause. The atmosphere is not that simple, and anyone who tells you it is should be viewed with some skepticism, including me. But there are patterns underneath events like this one that deserve honest examination. The blocking pattern currently setting up over the western Atlantic is not unusual in isolation. Blocking highs are a normal feature of atmospheric circulation. What has been documented, and this is in the peer-reviewed literature from multiple research groups working independently, is that the frequency of persistent blocking events over the North Atlantic has been increasing. The jet stream, the high-altitude river of air that drives weather system movement across the northern hemisphere, has been showing a tendency toward slower, more amplified wave patterns. Slower waves mean slower-moving weather systems. Slower-moving weather systems mean longer duration events. A heat wave that in 1980 would have lasted 3 days now has the atmospheric infrastructure to last 7 or 10. The Gulf of Mexico sea surface temperatures that are fueling the moisture surge underlying this event are running above the seasonal average. This is consistent with a documented multi-decadal warming trend in the Gulf. A warmer Gulf evaporates more water. More evaporated water means more moisture available to the atmosphere. More atmospheric moisture means heavier rainfall rates when storms do fire, more latent heat energy available to drive storm intensity, and higher dew points across the entire region downstream. These are not speculative connections. They are physical relationships with well-understood mechanisms that show up consistently in the observational record. The honest statement is this: the individual event you are experiencing this week is weather. The increasing frequency of events with this character, compound threats, multiple simultaneous hazards, extended duration, is a signal. Whether you choose to engage with the source of that signal is a conversation for another day and frankly a different channel. But the signal itself is in the data, and pretending otherwise does not serve the 70 million people who live on the East Coast. What you actually do about it. Let's be practical, because this is the part of the video that matters most, and the part that most weather content gets wrong by either being too vague or so alarming that people shut down entirely. Neither of those outcomes helps anyone. on heat. The single most important thing to understand is that air conditioning is not a comfort appliance during an event like this. It is a medical intervention. If you do not have reliable air conditioning in your home, and the overnight lows are forecast above 80 degrees with dew points above 70, you need to identify where you are going to sleep each night of the worst of this. Libraries, community centers, shopping malls, cooling centers operated by local emergency management agencies, any of these work. This is not about preference. This is about your core body temperature not rising to a dangerous level while you sleep. Check on your neighbors, specifically the elderly ones, the ones who live alone, the ones you have not seen in a few days. The mortality pattern from every major heat event in the historical record shows that the people who die are disproportionately people who were isolated. A check-in that takes 2 minutes can be the difference between a neighbor who survives and one who does not. Watch your pets. They are subject to the same wet bulb temperature constraints your body is, and they cannot tell you they are in distress until it is advanced. On flooding, this is the one where I am going to be direct with you, because the behavior problem here is specific and consistent and costs lives every single event. Do not drive through flooded roadways. I know you have heard this before. I know it sounds obvious. I know you are probably thinking of another driver, not yourself. But the data from flood fatalities shows that a significant majority of flood deaths occur in vehicles, and a significant portion of those involve decisions that observers afterward describe as avoidable. 6 inches of moving water can knock an adult off their feet. 12 inches of moving water can carry away a small vehicle. 2 feet of moving water will float almost any car, and moving floodwater does not look as deep as it is. Turn around, don't drown is a slogan because it is accurate, not because it is catchy. If the road ahead of you has water on it, you do not know how deep it is or how fast it is moving. The detour costs you 15 minutes. The alternative costs significantly more on severe weather. Know where you are going before day 7 arrives. In your home, that is the lowest floor, an interior room away from windows. If you are in a mobile home, you need a different plan, because a mobile home during a derecho event provides essentially no protection against significant wind. Identify in advance where you would go and make sure you can get there in the middle of the night if you need to. Because, as we established earlier, the atmosphere does not schedule its most dangerous moments for the afternoon. It does what it wants. If the power goes out and the heat is still on and you have no backup, the question you need to ask yourself on day 1 of the outage is not whether you can handle it. You probably can. The question is whether the person next door can, and whether the conditions will be the same on day 5 as they were on day 1. They will not be. Plan for the duration, not the first night. 70 million people live on the eastern seaboard of the United States. Over the next 10 days, they are going to face heat capable of killing healthy adults, rainfall rates that will overwhelm urban drainage infrastructure built for a different era, a severe weather window with a derecho threat centered on the most densely populated corridor in the country, and the compounding consequences that follow when all 3 arrive in sequence and the systems designed to protect people are already stretched. This is not a forecast of inconvenience. For some communities, for some individuals, for some families who do not have the resources or the information or the physical capacity to protect themselves, this 10-day period is going to be the difference between a story they tell and a story that gets told about them. We will be tracking every phase of this event and bringing you updates as the models sharpen and the threat windows approach. The atmosphere is already in motion. The question now is whether the people in its path are ready for what it is building toward.